Vincent,
Hi,
I think people have seen us on independent videos, but not in the same video before. So, do you want to give yourself a quick intro?
yeah, sure. Hi, my name is Vincent. I am a research advocate here at Rasa. If you've gone to PyDatas, you might have heard from some of the stuff that I do. But the way that this ball got rolling is Rachel was experimenting with reading papers, and then she figured, hey, it might be fun to just read a paper together. And then I kind of figured, yeah, we should try that. So that's why we're doing this. That's like it's a bit experimental, but that's also why we're doing it.
Yeah, I'm looking forward to this. And then I'm Rachel. I'm a senior developer advocate, and the paper we're reading today is the GPT-3 paper. So, Vincent, when we were talking earlier, you were mentioning that you weren't super familiar with GPT-2, which was
I'm not even familiar with GPT-1.
I there might have been a
To be
GPT
honest.
one, but like GPT-2 is the one that made the headlines. So
Ah,
it's
right.
you'll be shocked to hear this, a large transformer language model, and it's out of OpenAI. I don't know if you're familiar with them. It's
OpenAI, yeah. So that at least I'm aware of them. I think I've
mhm,
met them at a conference at some point. They're a research group.
mhm,
Originally, like I remember there was like a headline. Elon Musk was one of the funders
that sounds
behind it
right.
originally.
Yeah, they're a very well funded research group is how I would describe them. And I think they're down in San Francisco. They're definitely on the West Coast. And GPT-2 was their big language model that um,
Was
they're,
this the one they kept secret?
yes,
Ah, then okay, then
yes,
I remember. Yeah,
yeah.
okay.
And then GPT-3 is a bigger version of that. And it made a bunch of headlines because it was like generating news stories that were, I want to be clear about this, nonsense. They're not like factual, they're not grounded in anything. It's just like hallucinating words, basically. And this is the extension. And I have not read it, and neither of you. So we're going to be reading it for the first time together. Let's kick it off.
So
Coffee?
to get started, lots of authors as well.
Yeah. Uh,
I think one thing that might be valid to mention because I do not have an academic background per se,
mhm.
which is also partially why this is going to be an interesting thing because I don't read as many papers. I'm more of a person who reads blog posts. So
Mhm.
just top of my head, is it normal to see this many? It's not normal to see this many authors usually, right?
It it depends on the field. It's a little more common in computer science and NLP, um,
Oh, okay.
but I would say this is a lot of authors for an NLP paper. So, good question. So, language models are few shot learners. OpenAI. My thinking is that I'm just going to read until one of us has something to say, and feel free to just jump in.
Yeah, that works for
Um,
me. Sure,
and
go ahead.
also John Hopkins. Interesting. Oh, also their contributions listed in the paper. That's nice. So that's like specifically what every person did on the paper, so that
Yeah, okay.
credit is apportioned. Recent work has demonstrated substantial gains in many NLP tasks and benchmarks by pre-training on a large corpus of text, followed by fine-tuning on a specific task, like the BERT model, basically. While typically task agnostic in architecture, this method still requires task-specific fine-tuning datasets of thousands or tens of thousands of examples. By contrast, humans can generally perform a new language task from only a few examples or from simple instructions, something which current NLP systems still largely struggle to do.
Yeah, so far so good.
Yeah,
Um,
I mean, I think rule-based systems are generally a few simple instructions, whether like their amount of like flexibility is like a little bit.
Yeah, that's true. Well, yeah, no, true. Like one thing that, as far as rule-based systems go, one thing I kind of like about them is even if there's no data, you can have a rule-based system which guarantees like some insurance policy for the future. Which, if it's not in the data, usually a deep learning system's not able to capture it. So in
Mm-hmm.
that sense, I do think it's nice to mention that rule-based systems are not necessarily limited. I mean, that's definitely fair to point out.
Yeah.
Um,
And also tend to be a
but
little bit less unpredictable. So I know a lot of the places where people are doing natural language generation for commercial stuff, they generally do tend to do it rule based. So a lot of like news stories of like sports score reports, you'll have
mhm.
like a template, and then you'll like plug in using rules the team X won by X number of points. I can't use X twice here. By Y number of points.
Well, but also I think in production, something that I saw back when I was consulting, eventually systems that work really well that you don't have to maintain too much. Yes, they have machine learning in them, but usually the machine learning is like a part that is in the rule-based system,
Mm-hmm.
such as you can say, oh, there's high uncertainty, fallback policy, and there's still rule-based stuff. It's just that a node in the graph there would be a machine learning algorithm usually. That's a pattern I've seen work quite well.
Yeah, definitely. Not something that tends to do super well at academic conferences in terms of getting published, though. So
that I can definitely imagine.
Yeah. Okay. So current NLP systems still largely struggle to do.
Mm-hmm.
Here we show that scaling up language models greatly improves task-agnostic few-shot performance. So few-shot is you have a few examples. Zero-shot is you have no examples.
Mm-hmm.
I don't think there's like a shot for you have a lot of examples. Regular machine learning.
Yeah, that's the shotgun approach maybe, but I don't know.
Sometimes even reaching competitiveness with prior state-of-the-art fine-tuning approaches. Specifically, we train GPT-3, an auto-regressive language model with 175 billion parameters. That's so big. That's so big.
It sounds really big, yeah.
It's really big. I was reading somewhere that they spent $12 million on compute for this model.
Okay. No, so how much does BERT have? Just to compare.
10 billion? I have that figure.
Okay,
so
so
not to hand. It's big.
No, sure, but we can argue here that it's definitely an order of magnitude bigger than. It's a nice reference to have then.
Definitely. 10 times more than any previous non-sparse language model, and test its performance in the few-shot setting. For all tasks, GPT-3 is applied without any gradient updates or fine-tuning, with tasks and few-shot demonstrations specified purely via text interaction with the model.
So it sounds like they're pre-training a big thing, and then when they're sort of checking different things they want to do with it, I'm assuming maybe language generation, maybe classification, whatever, they don't change the pre-trained parts. That's what they're saying here, right?
Yeah, which is interesting, because there's some work on BERT in particular that shows that you don't necessarily have to do gradient updates for tuning. We'll see if they mention that work as well. Oh, interesting.
Yeah, because usually what one would do, you would have like one layer after the whole big pre-training thing, and that I believe that's common that you don't update the weights beforehand.
Yeah.
It's good they mention, but
because the model's so big, even if it's just like one layer, I don't know how wide it is, but several billion parameters, it's going to take a long time to update.
One would suspect, yes.
Seems likely.
Okay, no, but that's what they mention here, so I suppose that's fair to point out.
Yeah, and they'll talk about all of this in more depth. GPT-3 achieves strong performance on many NLP datasets, including translation, question answering, and close tasks, fill in the blank, as well as several tasks that require on-the-fly reasoning or domain adaptation, such as unscrambling words, using a novel word in a sentence, or performing 3-digit arithmetic. What?
So okay. No, so those sound a little bit more in the generation spectrum of things you can do with language models. So there's no like entity detection or classification, if I'm correct then.
Yeah, arithmetic? That's...
So I think it's like you have a string that's like 100 plus 102, and it has to do the arithmetic.
Yeah, no, but that's bonkers. That's wild that a language model should do that.
Why would it be wild for a language model to do that?
So they're not like knowledge models, right? They don't... A big sort of piece of criticism of existing large transformer architectures has been that they can't handle, like, they don't know that 3 is more than 2, right? So this is either very impressive because they're doing it from scratch, or trivial because the arithmetic problems exist in the training data and it's a memorization thing.
I doubt it's the latter, though, because there's
maybe. We'll see how much data they're using.
Yeah, they've not said what data they're training on, right?
No, and this is just the abstract, so presumably they will talk about it in more depth.
Okay, now that's a good thing to remember. I'm gonna write down some notes as we go by this. That's actually a good one.
At the same time, we identify some data sets where GPT-3's few-shot learning still struggles, as well as some data sets where GPT-3 faces methodological issues related to training on large web corpora. Okay, so they are like, hey, here's the drawbacks, which is always nice, because a lot of these, like,
Yep.
it's pretty common for, like, big system announcement papers to be like, here's all the things where we have state-of-the-art. You figure out where it's bad.
No, so that adding that one sentence is always appreciated. That I agree.
Definitely. Yeah, and I'm assuming they're going to go into more depth about all of these. Finally, we find that GPT-3 can generate samples of news articles which human evaluators have difficulty distinguishing from articles written by human. We discuss broader societal impacts of this finding and of GPT-3 in general. Why would you want to do this? Why is this a good thing to do?
Why it's good that they discuss societal impacts? I mean, I think
No. Societal impacts are good. Why would you want to generate news stories?
I mean, I can't imagine. I cannot speak on behalf of them because I wasn't in the group, but I can imagine that you would like to generate something that is somewhat in the realm of could be useful, and at the same time is also proving itself to, it's a non-standard thing.
But why not like fiction and something that doesn't have like an immediate adversarial application?
So that's definitely a valid comment. I can imagine that, like, a news article you can typically glance at and it has 10 sentences and it will work. I don't know many fiction stories for which that would also hold.
Yeah, you can do like flash fiction. Like, I don't know how common it is in the... I'm not going to say you only read stuff from the Netherlands, but at least in the US it's pretty common, like these super, super short stories that are like,
Well, so like if you have a
words.
newspaper... Yeah, so like when you have a newspaper, it's like, like a reader sends in a thing, and these things definitely do exist. I suspect maybe they wanted to talk about the societal impacts. Maybe I can imagine it if you're a research group, and I recall that this was something they were doing a little bit of marketing around as well. Like, hey, we also want to think about the applications, and AI safety was also a thing that they were working on, if I recall. So I think with that in mind, they probably just want to start get the ball rolling on this discussion. That's my assumption, and I suppose.
Yeah, like I don't think it's bad to talk about. I think it's a weird thing to advertise that your system can do, because there's like, I am having a real hard time coming up with completely benign applications of this.
That I agree with.
Anyway.
But then again, if their focus was to also get this discussion going, then I do think then that might be the angle they went for. That's something I can imagine, at least.
Yeah.
But anyway, that's the abstract. So far, so good.
That's the abstract, and this is wowee. This is the juicy one. I did not look at how long this paper was. Also, something that I noticed is they mention, like, in the abstract, they talk about like model size and the tasks that it's good on. They don't mention any like novel architecture stuff. Am I just missing that? Scaling up. Autoregressive language model, which is the same thing that GPT-2 was. So I think this is just a we did it bigger paper.
Potentially. Well, so, and the way that they judge it, right? So they don't specialize, is what they say. Which I don't know if that's common, but I think that if it turns out to be super general and they're the first group to show that it is, I mean, and still a bit empirical. We've done it in a big way. That's, I suppose, fine. But
yeah, I'm just thinking about this. So if I were evaluating a paper for as a reviewer for a conference, I'd be like, hey, what's the novel application here? Like, what's the new thing that they're doing that no one else has done before? And so far, what that seems to be is spending a lot of money, which.
Possibly. I mean, and so the one flaw, well, I won't call it a flaw, but the one drawback here is this is really hard to reproduce. And that's my main sort of itch here.
Yeah.
I'm not going to run this on my laptop anytime.
No.
I think.
No, I honestly don't know that I'd even be able to serve it on my laptop. Like, that's a chonker. All right, let's read the introduction.
Sure.
Recent years have featured a trend towards pre-trained language representations in NLP systems, applied in increasing flexible and task-agnostic ways for downstream transfer, which, I think BERT's probably the big one there that people tend to talk about a lot. GPT-2, T5 that came out pretty recently. Yeah. For single layer representations, were learned using word vectors and fed to task-specific architectures. Then RNNs with multiple layers of representations and contextual state were used to form stronger representations. Okay, so they're linking this into the text embedding literature.
Mm-hmm.
This still applied to task-specific architectures, and more recently, pre-trained recurrent or transformer language models have been directly fine-tuned, entirely removing the need for task-specific architectures. Also, I just want to say, I detest this citation style, like, to the depths of my soul. Because it's hard, like,
I was about to ask about it, but the citation style as in, like, you click it and then you go all the way to the back of the page.
So the clicking is not the problem. DL15 is meaningless to me, even though I think I've actually read this paper. I want the full names of the first and last author and the year that it was published, which you can kind of get from this.
But what is DL15 abbreviated? Is it the conference?
So die or day, and then le,
and then the year.
And then 15 is the year. Yeah, but that's so ambiguous, and I'm enough in this literature that I recognize usually full last names, but definitely not combinations of initials. Also, is this the NeurIP citation style? I don't think it is. I'm gonna check in another.
Possibly. The last time I wrote an article was when I was in my master's, and that was like well over 10 years ago. And the main part I remember of that experience was not the citation style.
I'm just taking a look. I feel like it's not, but I could be wrong about that. Anyway, that's my.
That's something you just have to get out there.
Yeah. Okay, NeurIPS uses just the numbers. So I think it's better than just the numbers, and then it'll pop you down, but still not mine. And it's 45 pages. Like, you had the page space. Just write the names out, please. For me and for people like me. All right. Do you wanna read some?
Sure, let's just check where you left off. So we have
right here, this last paradigm.
Yeah, so this last paradigm led to substantial progress on many challenging NLP tasks, such as reading comprehension, question answering, textual entailment. What is entailment?
Entailment usually means logical entailment. So if I say, all cats like catnip, Gawa is a cat, then Gawa likes catnip.
Right.
So
okay,
that's
I've seen it.
One example. Or like negation is usually a type of entailment.
Right, so that's a little bit, okay, fair enough. And many others. And has continued to advance based on new architectures and algorithms, and then a couple of examples. However, a major limitation to this approach is that while the architecture is task agnostic, there is still a need for task-specific data sets and task-specific fine-tuning. To achieve strong performance on the desired task typically requires fine-tuning on the data set of thousands to hundreds of thousands of examples specific to that task. Removing this limitation would be desirable for several reasons.
There's been a lot of work on pruning that shows that specific architectures are not task agnostic. So like if you prune a model based on, I need to find the exact citation, but specific transformer architectures are better for different tasks and can do really well even with just random initialization and no updating. So I don't know that the architecture is quite as task agnostic as all that.
Yeah, like this is one of those moments where it depends on the problem, maybe, I suppose. And I have to admit here as well, like the only problems that I've really tackled with anything NLP is either in the clustering, classification, or entity sort of domain. But for my use cases have been somewhat limited. I don't think I've been trying to do the super hard academic problems. But most of the stuff that I've just been using is just do a layer at the end, and that's usually an okay starting point. Okay, but let's check what else they have to say on this. So removing this limitation would be desirable for several reasons. Let's just see what they say about that.
Yeah, definitely.
First, from a practical perspective, the need for a large data set of labeled examples for every new task limits the applicability of language models. There exists a very wide range of possible useful language tasks tasks, encompassing anything from correct grammar to generating examples of an abstract concept to critiquing a short story. For many of these tasks, it is difficult to collect a large supervised training set, especially when the process must be repeated for every new task.
That's fair. Data's expensive.
Yeah, so I guess data is expensive. One thing I will say that, sure, a large data set of labeled examples is expensive, but then again, I also think that, but the reason is that it's expensive is typically you care. I think data management is usually, in practice at least, part of the problem, and we shouldn't discount it as something that we have to sort of expense. I think it's something you should do yourself, but it is expensive. So indeed,
no,
fair
definitely.
enough.
Yeah, and there's actually, I don't know if you've run into this, but there's a pretty big debate in sort of NLP research circles right now about the fact that data set papers have a really hard time getting published. So there's a specific conference called LREC, Language Resource EC. Let me just check that really quick. But
it sounds like a cool effort, to be honest, because I do I think it was like basic like MNIST as well, I think, had like a couple of these weird labels in there as well that are sort of a bit dubious.
Language Resources and Evaluation Conference.
Okay.
I don't know where the C comes from. But if you have an interesting new data set, it can be really hard to get published at conferences run by the ACL, and sort of a common review in conferences, do it at LREC instead. LREC happens every 2 years.
Okay, so it's less frequent.
Yeah, especially in like the domain of natural language processing research, which is moving very, very quickly.
True.
Anyway, and getting published at ACL conferences is like what helps you get hired and tenure, et cetera, et cetera, et cetera. So.
Yeah, I can imagine that there's conferences that have a little bit more oomph to their name.
Yeah, definitely.
But okay, so data sets are expensive.
Yeah, but no, I agree. There's, I think, definitely a trend towards sort of like discounting how important they are.
Yeah, and also in the end, it's something you want to control yourself in-house, I think. But that's a little bit more towards the application. Let's stick to the paper. Second, the potential to exploit spurious correlations in training data fundamentally grows with the expressiveness of the model and the narrowness of the training distribution. Okay, I'm going to read that sentence again.
Overfitting, basically.
Okay. Right. Okay. So, interesting choice of words.
So, I think by expressiveness of the model, they probably mean like over-parameterization. Like, if you have 1 billion parameters, it's much easier to overfit, basically, than if you have 10. And if you have
127 billion, there's also the opportunity for that, I suppose.
Definitely. And then if so one of the papers about BERT that was at ACL 2019 maybe found that so BERT's really good at detecting negation, right? And doing these sort of like contextual entitlement, looking at negation, except that what it was really good at was finding the word not and noticing when the word not occurred. And if you remove not from the training examples or from the testing examples, then you basically went back down to noise. So I think that's what they're referring to there. Although
so the examples that I hear where BERT seems to perform much better than anything else is where subtly takes it apart, but then I can imagine that there's still an opportunity to overfit if your data set is just not really covering a lot of ground. Fair enough, overfitting. And then they say about this that this can create problems for the pre-training plus fine-tuning paradigm, where models are designed to be large to absorb information during pre-training, but are then fine-tuned on a very narrow task distribution. For example, this paper observed that larger models do not necessarily generalize better out of distribution. There is evidence that suggests that the generalization achieved under this paradigm can be poor because the model is overly specific to the training distribution and does not generalize well outside of it.
I'm going to go down and then come back up to see if this is the citation.
Sure.
No, it is not. Interesting. I'm trying to remember the specific paper. Let me go back up 45 pages.
So reading that, I'm reminded of an analogy, and I'm kind of curious if you would agree.
Yeah.
So in image detection, what one would typically do is, like, if you want to detect a bike, for example, you would rotate the photo a little bit, you would flip it horizontally, etc. Of course, this trick doesn't really work if you only have one photo of one bike. You can flip it, you can generate millions of photos out of it, but you would have like a narrow distribution in that sense. Is that what they're alluding to here as well? That if your training data is just a little bit too specific, that you're not going to be learning that much because you're not covering a lot of ground? Would I be saying the correct thing here?
Yeah, no, definitely. Okay. I would agree. Also, I would say that that's not always necessarily a problem, right? Like if you have a chatbot that's, helping people with auto claims for a specific, insurance company, narrow is fine. Narrow is going to be better than general.
You're dealing with a subset of language anyway, and I would argue in such a situation you would prefer if the digital assistant will restrain itself to that subset.
Yeah, you don't want
if it was also otherwise it will start talking about fire hydrants and that sort of thing.
Exactly. It's like start bringing up birds or whatever. Not the most helpful thing if you're like, no, I need my claim filed like right now.
No, but then again, if you want to have a language model that is able to do both text from like a history book as well as a biomedical paper, then you need to cover a lot of ground all of a sudden. So
definitely.
Okay, so
although I guess my question is, when do you need that?
I believe that's an excellent question, but it seems that that's the problem they're trying to. That's at least the area where they're trying to tackle something here, right?
Yeah.
But that's the impression I have because they want to cover a lot of ground, is what I'm reading here.
Yeah. No, definitely.
Anyway, so I'll read the final sentence. Thus, the performance of fine-tuned models on specific benchmarks, even when it is nominally at human level, may exaggerate actual performance in the underlying task. Okay, so I guess I get what they're saying. Then we're nearing a diagram. You want to check one more?
I will, but I am going to check this citation first. Yes, okay, this is the paper I was thinking about. Niven and Cow, Probing Neural Network Comprehension of Natural Language Arguments, and it was published at ACL. Do not cite the archive preprint when the paper exists. Don't do it. Don't do it.
Was this in a time when only the preprint was an art? Well,
no, this paper just came out. Sorry, you were finding out all my pet peeves as a reviewer, as a conference reviewer.
You've reviewed conferences before.
Oh yeah.
Okay. So I've only reviewed a PyData before, and from what I'm gathering already, it's a different experience.
It is. Because it's so at least in NLP, conferences are sort of on par with journal publications in terms of how fancy they are.
Well, and to a lot of people, I think PyData is a bit different, of course, but if someone speaks at PyData, they're going to put it on their resume. And I can also imagine if you publish on a certain year at a conference, then you're also going to put that on your resume. It's a bragging right.
Yeah, and not just your resume, on your CV. So for academic jobs, you want as many publications as possible, and a good conference publication counts for a lot. All right, I can just read the figure. So figure 1 point. Oh, go ahead.
Well, I think have we seen the figure prompt? Oh, the figure is lower.
It's down here. Okay, yeah. Let's keep reading then.
Yes. Okay, I'll wrap up this paragraph and then we'll switch back to you then.
Sounds good.
So third, humans do not require large supervised data sets to learn most language tasks. Is that true? Because when I went to preschool, I was corrected all the time for like 8 years straight.
Yeah, that doesn't help kids learn. Yeah, I guess the question is if you're talking about once you've acquired a language, if it's a fairly specific task, I think people can learn with fairly few examples. So,
in that sense, right. So given, take the average, 20-year-old from the street and their understanding of language, then you can come up with a somewhat arbitrary language task and they can very easily learn it.
Yeah, or without needing underline all the colors, right? You know what the color words are and you can just be like, oh yeah. Or even if you haven't seen a color before, like, I'm trying to think of a weird color. Petrol. Like, petrol is a color. Even if you don't know that that's a color, if you're like, the curtains were petrol and, I don't know, yellow, you'd probably, like, underline petrol as a color.
Yeah. Okay, so, fair enough. A brief directive in natural language. Example, please tell me if this sentence describes something happy or something sad. Or at most a tiny number of demonstrations. Here are 2 examples of people acting brave. Please give a 3rd example. Okay. I get where they're going with this. and it's sufficient to enable a human to perform a new task or to at least a reasonable degree of competence. Aside from pointing to a conceptual limitation in our current NLP techniques, this adaptability has practical advantages. It allows humans to seamlessly mix together or switch between many tasks and skills, for example, performing addition during a lengthy dialogue. To be broadly useful, we will someday like our NLP systems to have this fluidity and generality.
Yeah, this is true of humans. Go ahead.
Yeah. Okay. So I guess this is again it's a similar theme though, because they're emphasizing the need for something general. That's what I'm seeing here. Except here they're focusing on learn once and then only need very few examples to learn a new task.
Yeah. Yeah. Hopefully they talk a little bit more about human learning here, because they're making a lot of sort of like I don't know. There's a lot of research on how humans learn to do things with language, and I don't see a lot of citations in here.
Yeah, no, I would agree. Then again, I can also imagine, since this is so I'm assuming this is written by AI people, and therefore that's the area they're going to have to focus on, of course.
That's true. But I mean, like, psycholinguistics is a whole thing, and if you're going to make claims that your model does what human do, you should know what human do.
No, and your point is valid, right? Like, you could have like a reference to an article here, because it definitely feels very plausible that studying how humans learn is something that's going to be relevant if you want to have a machine to do it. But anyway, okay. But in the that said, I do think that's the point that they're trying to make here. Like, learn one thing generally, such that later it's very easy and without too much training to learn a new specialized task. That's what they're suggesting. Anyway.
One potential route towards addressing these issues is meta-learning, which in the context of language models means the model develops a broad set of skills and pattern recognition abilities at training time, and then uses those abilities at inference time to rapidly adapt to or recognize the desired task, illustrated in Figure 1. Is that what meta-learning means? Let's read this.
So there's a footnote and a figure in this case.
Yeah, let's do the footnote first, because that is not my understanding of meta-learning in this context. In the context of language models, this has sometimes been called zero-shot transfer, but the term is potentially ambiguous. The method is zero-shot in the sense that no gradient updates are performed, so they don't change the model once it's been formed. But it often involves providing inference time demonstrations to the model, so it is not truly learning from zero examples. To avoid this confusion, we use the term meta-learning to capture the inner loop, outer loop structure of the general method, and the term in-context learning, I think that dash is probably the wrong place, to refer to the inner loop of meta-learning. Okay, so they're using meta-learning to mean transfer, what I would probably call transfer learning. We further specialize the description of zero-shot, one-shot, and few-shot depending on how many demonstrations are provided at inference time. These terms are intended to remain agnostic on the question of whether the model learns new tasks from scratch at inference time or simply recognizes patterns seen during training. This is an important issue which we discuss later in the paper, but meta-learning is intended to encompass both possibilities and simply describes the inner-outer loop structure. Okay, so...
A figure would help me here in particular. This is a bit dense.
Yes, it is. Okay, so yeah, it is supposed to be in context. Language model meta-learning. During unsupervised pre-training, a language model develops a broad set of skills or pattern recognition abilities. Does it?
Okay.
It then uses these abilities at inference time to rapidly adapt to or recognize the desired task. We use the term in-context learning to describe the inner loop of this process, which occurs within the forward pass upon each sequence. The sequences in this diagram are not intended to be representative of the data a model would see during pre-training, but are intended to show that there are sometimes repeated subtasks embedded within a single sequence.
So it sounds like they have so correct me if you interpret this differently, but so they have this pre-trained model at some point, and they have some texts, and then they're going to have on the same text multiple tasks?
Yeah, I think that's what they're saying. But they're also saying the model's never updated, but they do show examples at inference time. If you don't update the model, why would you show examples? Or so maybe there is another layer, like there's another classifier.
That's my interpretation. So what is the model in this case, right? So it feels like they've got the big pre-trained model, and that remains untouched. But
and then the example here is also on top. How is that different from embeddings?
That's a good one. No, so I suppose embeddings. Yeah, because you call them BERT embeddings at some point as well, because they're not separate embeddings for separate tokens, but it's still text goes in and numeric representation comes out.
Yeah.
But what I find confusing about this figure is the tasks are all substantially different. So I can't imagine doing SGD on them at the same time if these are all separate layers. So you have one separate layer that will do the in-context learning for addition, the other one for spelling correction, the other one. But those are, I am assuming those are all parallel.
Yeah.
As in they don't influence each other.
Because why, like, are they saying that they're using one sequence sometimes repeated subtasks embedded within a single sequence? Are they doing addition, unscrambling, and translation in a single task? That seems ridiculous. When would you see that example?
No, that feels implausible. So there's just, what does the purple arrow represent in this case? So you got the inner loop and you got the outer loop. Learning via SGD during unsupervised pre-training.
In context learning. So I think that they just have like another model on top of the. So they have the big model that doesn't change, and then they have the inner models that they do update, and they just don't change the pre-trained model. Is what I'm getting here.
Or the pre-trained, or while the unsupervised pre-training is learning. The other tasks are also learned. Oh, but they pre-train. That's what they said in the abstract, right?
Yeah, this is either like just the same thing that people already do, or I'm completely missing what they're saying here.
Yeah, so the thing. Okay, I think this is exactly the thing that that people normally would do. That's because that way I can understand it. So it's a little bit.
Also,
that I'm.
Just to quickly pull in, my usual understanding of meta learning is that it's a type of AutoML where you sort of like learn about model parameters that would work for a specific task, which I think is not quite what they're doing, because they're saying they don't change the model at all. Maybe this is just a use of meta learning I'm not familiar with. Familiar with. I don't know what that was. So like.
So it is an issue in our field that, especially because we're in language, it is a bit ironic that in our field we have a couple of words that really mean different things but have the same token, and that we have multiple meanings that use the same token. The fact that this is happening, and it feels like a lot in natural language processing, is a little bit ironic.
Yeah, and I don't think, just sort of looking at the thing here, system must include a learning subsystem. Experience is gained by exploring meta-knowledge extracted in previous learning from different domains. Maybe this does. Anyway, this is just sort of, this is not necessary. I don't think I would call this meta-learning, but maybe I just haven't been in this literature as long. Right. I still don't get what they're saying. Maybe more examples.
Okay, but yeah, so we'll read a bit further. But for all intents and purposes, it does feel at least like you're still doing something pre-training, and then what comes out of the pre-training, many different specialized tasks will be performing well at some point. So we might come back to this later.
Yeah.
But,
Recent work attempts to do this via what we call in-context learning, using the text input of a pre-trained language model as a form of task specification. The model is conditioned on a natural language instruction and/or a few demonstrations of the task, and is then expected to complete further instances of the task simply by predicting what comes next. Oh, I see. Okay, so this is like text generation. If I started my text generation by being like, cats are animals, animals eat food, cats eat blank, and then expecting it to fill in food. So they're just doing things through Okay, so they aren't changing the model. They're providing examples, and then they're having the model continue to fill in the blanks, which is something that they did a lot with GPT-2. So I guess this isn't that weird of a thing.
Right,
Okay.
but then it's not just so it's not just mere text generation. It's also some of these specialized generative tasks.
Yeah. So let me see. There's like a GPT-2 demo online. Someone shared a while ago. I'm just gonna really quickly see what that blah 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 blah. That's not it. Anyway, I can't find it real quick. Gotcha. Okay, so they're saying that they're just sort of like seeding the text generation, basically. Well, it has shown some initial promise. This approach still achieves results far inferior to fine-tuning. For example, it'd be great if I had the names of the authors right there. Achieves only 4% on natural questions. And even its 55 F1 COCA results are now more than 35 points behind the state of the art. Meta-learning clearly requires substantial improvement in order to be viable as a practical method of solving natural language tasks. Another recent trend in language modeling may offer a way forward. In recent years, the capacity of transformer language models has increased substantially, from 100 million parameters to 300 million parameters to 1.5 billion parameters to 8 billion parameters, 11 billion parameters, and finally 17 billion parameters.
Okay, I have to ask, why do you think they added every step in between there? Were they like epic milestones, or?
I'm trying to remember. I think this one is BERT. Yeah. It's an EMNLP paper. Cite the paper, not the archive. Authors, that goes for everybody. If I'm reviewing your paper and I know a paper's been published and I see you citing the archive link, I will leave you a nasty comment. No, that's not true. I'll point it out and be like, fix it. I know it's very common. I know Google Scholar will sometimes default to the archive. It is your job to keep track of the scholarship, researchers.
I think I will say that I do find for blogs archive being quite nice, mainly because you can just link to the PDF. But in academic context, I do see the downsides.
No, if you're citing a piece of literature in a paper and you're a researcher, it's your job to be familiar with that piece of research and its provenance and where it's been published. Like, that is part of the job. Update your citation databases.
But then still, okay, but I'm assuming then that we have all these millions of parameters and these are milestones. But then they say that the capacity of transformers has increased substantially. But are we then saying like been advances in the transformer architecture, or is it just, hey, we've been able to throw more compute at it?
Yeah, I think pretty much that.
Probably the latter, right? Okay.
Yeah. I think Elmo is LSTM, so what would this one be? I don't know. I don't remember all of the specific models.
But
I'm
Elmo
pretty sure this is T5.
But Elmo if Elmo is LSTM, then it's not transformer, is it?
No,
or...
it is bidirectional, so it goes forward and backwards. There's two LSTMs. Yes. Each increase has brought improvements in text synthesis and/or downstream NLP tasks, and there is evidence suggesting that log loss, which correlates well with many downstream tasks, follows a smooth trend of improvement with scale. Since in-context learning involves absorbing many skills and tasks within the parameters of the model, it is plausible that in-context learning abilities might show similarly strong gains with scale. I don't know that skills and tasks are what's being learned. Collocations are being learned.
Collocation? What's that?
So that things occur together, basically, because they're essentially language models, right? They're what things are liable, what words are liable to be used together, and that's not this, like, knowing that cat and dog get used together is not the same as being able to do the task of identifying an animal, you know? I don't know. This paper has kind of a lot of my personal pet peeves in it, which is like, that's on me. Sorry, was that Vincent?
No, so I think you have what you're saying has merit to it. That's my main observation. It's just I cannot comment too much on the sort of pet peeves that you have in the article, mainly because I don't read that many articles. But but the one thing like, I'm a person a little bit more from practice, so I'm really curious. Like, they're doing a whole lot of effort. So this, right? So, and also so many million parameters, and this is a
Yeah.
super expensive thing to train. So,
Yeah.
um, like I'm curious to see where this is gonna go in that sense, because
Yeah, definitely. Yeah, I don't. So again, putting on my like conference reviewer hat, I don't know that this is necessarily. I don't really know that this is like a good novel result, right? Because they're just saying, hey, it looks like if we keep doing bigger models, they do better. And I imagine the rest of the paper is going to be like, we have a bigger model, it do better, which I think is established at this point, you know, at least in the literature. And I don't know, maybe they're doing other things that are also useful, but so far I'm like, okay.
I mean, I don't know if this is something the academic community would then accept, but I can
Mm.
imagine, hey, we made it twice as big. It didn't perform any better. I mean, that also would be an interesting paper, I think, right?
Yes. Yeah, I think that would be
Um,
very interesting. And that would have maybe less of a chance of getting published, actually,
well,
unfortunately.
so then if so in that sense, I can imagine people trying out bigger models all the time. I mean, there's also like a technical challenge, like engineering wise, you're going to learn stuff. So I can imagine why people do it.
Hmm.
And I think reporting that then, hey, the metrics increase, I think is fine. Um, it's not terribly interesting, but I do think reporting we made it bigger and it works better. I think that has merit to it.
Yeah.
That is something I am comfortable saying. I mean,
Yeah, I think that is, I think you're right. I think it's definitely interesting from an engineering perspective. I don't know that that tells us much about language, you know? And I
oh,
don't
that's true.
know that it's
That's true.
necessarily helpful to other practitioners. Because I'm not going to sit down and train 100 billion parameters for, you know, building a virtual assistant. Like, I'm just not going to. Why would I? Um,
No, but I can imagine at some point there's gonna. I'm assuming there's gonna be something of a chart somewhere that says, okay, suppose you 10x the number of parameters. You probably don't 10x the performance numbers.
mm,
It's probably marginal,
yeah.
and sort of quantifying that delta, I think, can be useful.
Mm, yeah.
The lesson's probably going to be not worth it, like for a practitioner like me,
Yeah, yeah.
but measuring that, I think, can have merit to it. But let's keep reading.
Yeah, definitely. Um, blah, 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 blah. In this paper, we test this hypothesis by making a really big model and measuring
Yep.
its in-context learning abilities. So basically, we tried to generate answers.
Mm-hmm.
Specifically, we evaluate GPT-3 on over 24 NLP datasets, as well as several novel tasks designed to test rapid adaptation to tasks unlikely to be directly contained in the training set. Did you check? Are they not in the training set? Like that is important.
Well, yeah. So I think the word unlikely is a little bit dubious.
Yeah, we'll see.
Uh,
Maybe they.
also-
Hopefully they did.
it's actually two words. It's unlikely to be directly.
Oh.
Uh,
For each task, we evaluate GPT-3 under three conditions: few-shot learning, or in-context learning, where we allow as many demonstrations as would fit into the model's context window, typically 10 to 1,000; one-shot learning, where we allow only one demonstration; and zero-shot learning, where no demonstrations are allowed and only an instruction in natural language is given to the model. Okay, so the instruction would be like, give me an example of a color, and then you generate whatever the next thing would be. GPT-3 could also, in principle, be evaluated in the traditional fine-tuning setting, but we leave that to further work. Yeah, I'll just use my, couple million in compute to fine-tune this behemoth. Figure 1.2 illustrates the conditions we study and shows few-shot learning of simple tasks requiring the model to remove extraneous symbols from a word. Model performance improves with the addition of natural language task description and with the number of examples in the model's context, K. Few-shot learning also improves dramatically with model size. Though the results in this case are particularly striking, the general trends with both model size and number of examples in context hold for most tasks we study. We emphasize that these learning curves involve no gradient updates or fine-tuning, just increasing the number of demonstrations given as conditioning. 1.2.
oh, didn't we just? Oh, yeah, that's that one.
Larger models make increasingly efficient use of in-context information. We show in-context learning performance on a simple task requiring the model to remove random symbols from a word, both with and without a natural language task description. The steeper in-context learning curves for large models demonstrate the improved ability to learn a task from contextual information. We see qualitatively similar behavior across a wide range of tasks. Okay, so what they're saying is if you have, so this is the biggest model, this is a medium model, and this is the smallest model, all of which are bigger than I would choose to use.
Yeah, exactly. So the 1.3 billion parameter, that's the diet model. Okay, sure.
So zero shot is nothing. The dotted line is they don't have a prompt. So just like randomly generating something. And then the solid line is they do have a prompt. So like, give me an example of a color, for example. And then looking at the number of examples, so 0, 1, and 10. And as these go up, why is the scale like this? I guess they're trying to show logarithmic growth. So the bigger the model, the better you do, and the better you do with fewer examples is the thing that they're saying. Or the faster you learn with fewer examples.
Yeah, so I'm a little bit, I wonder why they use the word efficient.
I guess efficiency with regard to...
They're saying it's increasingly efficient.
Mm-hmm. So you're better able to use less information?
Okay, okay, that's okay.
Also, the accuracy is still below 50%. And this is remove random symbols from a word. So these are they inserting non-ASCII symbols into text and asking the model to remove it? Because if it's a word that it's seen before without the symbol, that seems like maybe not a... But if you don't give it any information, it doesn't do it at all.
So then you get the spelling correction task, essentially.
But it's not... So it doesn't sound like they're misspelling words. It sounds like they have a word like...
like dollar symbols.
CHOC, yeah, like smiley face. OLAT. I'm trying to spell chocolate. I don't know if that was... I don't know if I managed it. That's a weird task. That's not like a normal task. I don't...
Do they explain why they chose that task?
Not there.
I mean, there's multiple tasks they said, right?
Mm-hmm. Yeah, but also the other tasks that they brought up are unscrambling. So this is a very specific type of spelling correction, arithmetic, and then translation. Translation is a common NLP task. These other ones aren't really.
So one thing that pops to mind, this is mainly because you've done lots of scrolling. I think I saw a bit of the appendix. Did you have like very similar charts in the appendix for different tasks?
Yeah, let's see if we can find out. Results on all tasks for all model sizes.
Bingo.
Oh, this is great to read.
Oh, man.
All right. So this is going to be translation, English to German, German to English.
What does this mean there?
What is what?
So English RO, that's a year from a data set or something? Or?
I think it's the size of the data set.
Okay.
I think. Wow, this would just be easier to do as a chart, huh? Maybe it wouldn't. This is a lot of information here. The Winograd schema is resolving ambiguities in structure, basically. Hella swag.
Okay, now but we do see like lots of different tasks here, right? So
these are
the only thing
question answering.
Right. So one thing that so the first one was zero shot, then many shots, or?
So zero shot, one shot, few shot.
Two.
And then small, medium, large. So the models get bigger over time.
Okay, so one thing I see one number already that just makes it a little bit weird. If you go to Winograd, it seems that the zero shot is performing better than the one shot. Does that make sense?
Yeah, it does seem like that, doesn't it? And that's pretty consistent. I don't know. Let's pull up some examples. So these are a little bit of a weird. It's a little bit of a weird task.
It feels like they have many tasks, though, right? So, like in the sense that what they argue in the beginning, hey, we're trying to run this on many things. I do think that looking at the appendix is valid. Like it's.
Okay, so this is the difference here is, so the city councilman refused the demonstrators a permit because they feared violence. So feared is something that the councilman is doing here. The city councilman refused the demonstrators the permit because they advocated violence. Advocated is attached to they. So the structure of the sentence changes depending on the verb, but it doesn't change on a surface level besides just the one word being changed.
In this particular case, though, advocated, could it also refer to the demonstrators in this case?
Yeah. Oh, sorry. So it's the they. So
right.
Here,
oh.
Yeah.
Yeah. Okay. Okay.
They councilmen, they demonstrators. Yeah. Thank you. Good.
Okay.
Good idea.
No, that's,
And this in particular is the task that Bert. Is it? So this is Wino Gradscum as a part of the glue evaluation. I'm pretty sure the glue evaluation. It's a metadata set. I'm sure you've run into discussion of it before, and I'm pretty sure that's one of the ones that Bert did particularly poorly on. What?
So one thing that seemed interesting. It does see.
Oh, it's perplexity. I was like, 165% accuracy, huh?
So one thing that's interesting, if you scroll down, at some point you do see that the zero shot just has abysmal scores. So the bull queue, and there's a couple of them, and then you do the one shot and they do way better. It just I do find it interesting though. Like the Winograd data set, how big is that? Because if the zero shot is doing way better, like
let's see.
Are those metrics like statistically significant?
I mean, there's one sample, so it's hard to say, right?
Right.
It doesn't have the size of the data set here. I don't think it's very big because these sentences are fairly rare, and they're all naturally occurring. So, oh, here's another one, the analogies. So zero shot was much better than the other ones. For the small models, for the bigger models, zero shot was worse.
Right. Okay. So that's right. And in here, I guess we see the same charts as we saw earlier. These were the charts I remember seeing. Exactly.
Yeah.
So those are the numbers we just saw, but in charts.
Yeah, like this. What is this? It's something in context, I think. They're random guessing, basically. And again, zero shot is actually worse than random guessing for some of these tasks as well. Oh, here we go. So this is the Winograd Schema Challenge, and you can see that Bert and random guessing are basically on top of each other. Interesting. So it does look like, I mean, we obviously haven't finished the paper, but it looks like their main contribution is that just going ham and having a bajillion parameters does seem to be better.
Yeah, but especially in the charts that you see, that we just saw, if you could scroll up just a little bit, because here you see here you see a couple of charts where there's a big difference, right? So, and a lot of these are addition tasks.
Yeah.
So that is why why they mention the addition task, because this difference. So this difference is very apparent in this task. So that's why they explicitly mention it in the beginning, I think.
Yeah, I wonder if there was addition in the data set. Like maybe that's the problem. I not that it's a problem, but that is very weird because the rest of these sort of show gradual improvement. Also, why are you using a language model for addition?
Also, so part of me wonders, like, because it's such a weird task, maybe you could argue that that's also why it's so interesting if it works.
I guess.
This is a hypothesis, right? It's a hypothesis.
Yeah. Actually, let's see if we can like learn more about the addition task in specific, because that's one thing that's sticking out to me is like definitely unusual results. This must be the probably synthetic and qualitative task would be my guess, unless they're trying to argue that it's natural language inference, which seems there we go. Yeah.
Arithmetic. There you go.
To test GPT-3's ability to perform simple arithmetic operations without task-specific training, we developed a small battery of 10 tests that involved asking 10 tests. That's not that many. That involve a simple arithmetic problem in natural language. Blah, blah, blah. All right. Few shot. So I'm just sort of scrolling here to see if they talk about why they chose to do this. No. Nope.
No, but I can imagine it is a because it's such a non-standard task.
Mm,
I think, being super honest, it's probably because there's such a huge improvement that it is a bit of a bragging right. So we should add that to the paper. I think that part of the truth is probably there. That
yeah.
said, I mean, you will have some text out there that has some arithmetic in it,
Yeah.
like a dish. It doesn't feel super invalid to me actually that they add it. They do seem to put a lot of emphasis on it though. Like that's
Let's check out the training data. I think that'll help us, or at least help me.
not sure.
Blah blah blah.
But
They use
one thing
Common Crawl? Go ahead.
okay, so I don't looking a little bit at the time. I think we're going to actually get at the model, but so far it sounds like this is just BERT.
Yeah, I think they had some differences. It sounds like an extension of GPT-2, and I think the biggest difference was the auto regressiveness. But yeah, I don't know that, like, from an architecture standpoint, this is especially interesting.
Exactly. So now then the main thing that we're looking at evaluating is just more weights.
Yeah, I think so.
Which is interesting. But it's okay. But then, as far as data goes, they say Common Crawl
and books too.
Huh.
Web text too. Wikipedia, which I think almost certainly has some addition in it. Okay, so it looks like capacity to memorize. Yeah, absolutely, definitely a problem, particularly with the way that they are evaluating. A major methodological concern with language models pre-trained on a broad swath of internet data, particularly large models with the capacity to memorize vast amounts of text, is potential contamination of downstream tasks by having their test or development sets inadvertently seen during pre-training. To revert... Oh, so they looked for, like, the exact data sets that they are using, but they didn't look for very similar examples, which, I mean, very possibly could have occurred in this extremely large data set. Unfortunately, a bug in the filtering caused us to ignore some overlaps, and due to the cost of training, it was not feasible to retrain the model. In Section 4, we characterize the impact of the remaining overlaps, and in future work, we will more aggressively remove data contamination of this particular type.
I appreciate they're honest about it.
No, definitely.
I mean, that's...
Models did perform moderately better on data that overlapped between training and testing. This did not significantly impact reported results due to the small fraction of data which was contaminated, only a few %.
Yeah, but yeah, okay, but if your improvement of state of the art is also just a few %,
yeah,
you gotta be careful.
Yeah. So we obviously haven't finished the paper, but my reaction so far is it's basically an extension of the state of NLP for the last, like, I don't know, 10 years. Bigger models are doing better. That's great. I don't know that I'm convinced by their evaluation metric. I don't know that I'm convinced by their evaluation strategy, especially because this is not a common way of evaluating models. And it looks like they did do it for some other models as well. Scroll. So if I remember...
That's a good comment. I was also wondering, so I would... So I guess the other model, if they just use BERT as a starting point, they just retrain their own version of BERT. So I guess that's what they're...
So I don't think they use BERT as a starting point. I think the architecture is different, but the architecture difference is not is something that OpenAI did earlier with a different model. Right. So it's an extension of their earlier model, not an extension of BERT necessarily.
No, okay, that's fair to point out. But they're comparing against their own internals in that sense, and I would be interested in maybe knowing, suppose you should have like a much lighter model, but it's super specialized towards that task. How would you fare?
Yeah, that's a good question. Looking at how well it's doing compared to fine-tuned state-of-the-art on a lot of these tasks that people generally do, worse, it looks like.
Well, unless you go for the bazillion weights thing at some point.
But so here's the model. This dotted line at the top is, I know it's a little bit small, is fine-tuned state-of-the-art, fine-tuned state-of-the-art, fine-tuning.
But it depends on the task, though, right?
It does depend on the task. Yeah. But I would say, in general, for most of these tasks, it looks like it's not overwhelmingly beating state-of-the-art.
It is doing many tasks though. Like
Mm-hmm.
just looking at that one page in the appendix with all the numbers, I mean,
Mm-hmm.
it is a lot of tasks that are running. So
Definitely.
so that is something we should that feels valid to acknowledge, I think.
No,
Uh,
definitely. They ran a lot of evaluations. I will
yeah.
agree with that. Uh, yeah, and it's only worse than random guessing on a fair portion of them. I don't know. This is I will say again, this is a personal bias. This is the type of research question that I think is like honestly not that interesting.
Well, so and I kind of second that because suppose I'm a company and I'm interested in like suppose let's say I'm a company and I have an enterprise use case for 2 out of those 70 odd tasks that they're running.
Mm-hmm.
Then this would still not be something I would do to production, maybe, because probably I can specialize and it'll be cheaper to A, train, and B, the performance, depending on the task, of course, may be better.
Yeah. Yeah, I've mentioned before in different channels that the NLP papers these days that I'm really excited by are the ones that use smaller models and reduce model size and training time in clever ways that still improve results. And again, you mentioned from an engineering standpoint, I think this is really interesting. I think it does like, yep, if you spend more money and have a bigger model, it does get better as it gets bigger. But at this point, like, I personally, as a practitioner, think that this is completely unreasonable. I think this is
Well,
like, who would do this?
and also I think it's fair to mention if you're interested in an engineering task, getting something like this to run on a Raspberry is also a very interesting engineering task. I think.
Mm-hmm.
Like it's nonsense that interesting engineering tasks are only happening on big clusters of machines. Usually, getting to the nitty gritty low level stuff is also just exciting.
Yeah,
Uh,
that's a good point.
but
Okay.
but yeah, like, I do think we can still have another look at this though, because I do think there's
Yeah.
there's some stuff in here that's worth checking out. And one thing I've never like I have heard of this GTP number stuff,
Yeah.
but I will say that this has been fun because looking at the charts, it does normalize it a little bit,
Mm-hmm.
and also something at least personally I'm noticing. Reading these sentences out loud really makes it easier to understand because these papers are dense.
Yeah. No, I would definitely agree. The reading out loud is long been my preferred way of getting through things. Which there's a reason I didn't do a lot of my readings in the grad student office when I was in grad school. It was not necessarily a delight to be around. Yeah. All right. Well, thank you for joining me, Vincent.
Yeah, thanks for inviting me. It's been
This
fun.
has definitely been an interesting paper. I don't know. I think my problems with it are more like fundamental disagreements about what the role of NLP should be, and less I think it's a bad paper. But if authors, if you're watching this, please don't cite archive. If I'm a reviewer for this, which I mean, it wouldn't be this version because this is I think ACL papers are like maximum 8 pages, so it would have to be a subset of this paper.
The one thing I do think is valid, like I do think that the goal, let's try to find like the whole switch towards general embeddings. That's valid. I think that's okay to mention here. But man, but 127 billion, that is a lot. That's big. Yeah.
All right. Well, thank you, Vincent.
Okay.
Thanks for joining me, and I will see you next time, and we'll keep digging into this paper.